Thank you for joining us today for choosing a big data technology stack for digital marketing from Semphonic and IBM. A few housekeeping items. We will be recording this webinar and posting it online tomorrow so you can view it again. We will also send you an email when this is posted. You can follow today's live webinar at the hashtag BigDataTech on Twitter. We will be tweeting updates and comments about the webinar, so please feel free to join us there with your comments. Presenting today is Gary Angel and Krishnan Parasuraman. Gary Angel is the co-founder and president of Semphonic, the leading independent digital analytics consultancy in the United States. He has led Symphonic's analytics practice and consulting for more than a decade. Gary's work in web analytics includes the development of online behavioral segmentation systems, creation of several core web analytics methodologies, including functionalism, and the development of SEM analytics for PPC marketing. Prior to Semphonic, Gary worked in the credit card database marketing industry, developing transactional analysis systems for marketing purposes. Gary is the recent recipient of the Digital Analytics Association's Award for Excellence as the most influential industry contributor. Gary blogs regularly, and you can find his blog on Symphonic's website. From IBM, Krishnan Parasuraman is CTO of IBM's Big Data Solutions, and in his role, he works very closely with customers in an advisory capacity, driving big data solution architectures and best practices for management of internet-scale analytics. Krishnan is an authority on the use of big data technologies, such as Hadoop and massively parallel data warehousing technologies, towards solving analytical problems in the online digital advertising, customer intelligence, and real-time marketing space. Krishnan speaks regularly at industry events, writes for trade publications, and is the author of the book, Harness the Power of Big Data. So just one more reminder, you can follow us at Big Data Tech on Twitter, and now I'll be handing it over to Krishnan Parasuraman.
Thanks, Kate, and welcome everybody to our webinar. So today we are going to focus on choosing a big data technology stack for digital marketing. And one of the things that we are seeing amongst our customers is the rapid growth of digital data. And digital data in this context means clickstream data that is generated by user activity on websites, email responses, click-throughs, search-related activity, social engagement, or any type of digital interactivity between content and a consumer. And digital marketers use this data to provide, let's say, better offers to their customers, improve segmentation, enhance precision and relevance of their messages. And this is fundamentally an analytics and optimization problem. And in the technology world, we have been solving analytics and optimization problems for decades now. But there's something about analytics, especially in the context of digital marketing, that makes it very unique. It makes it very challenging. And we have seen our customers grapple with that, struggle with that, and even fail on digital analytics initiatives. So today, we would like to explore the characteristics and needs of digital analytics and see why it is such a difficult problem to solve. And we'll also look at what makes traditional technologies, especially traditional database technologies, inadequate to meet that demands of digital analytics. And Semphonic has come up with this great framework that helps digital marketers and technologists identify the right set of capabilities for their different use cases, and then select the right technology stack. And finally, we'll also take a brief look at what IBM is doing in this space and how its offerings are meeting the demands of digital marketing. So with that, let's get started. But first, I'll ask Gary to give a quick introduction of Semphonic. Gary?
Thanks, Krishnan. And you know, there's no introducing IBM slides here because I think probably everybody knows you guys, but I thought it might be helpful just to give everyone a quick couple minute, and I'm not going to spend a lot of time on this introduction to Symphonic. As Kate mentioned in the introduction, we've been doing digital measurement and consulting for the last 15 years, actually, so really since the dawn of the Internet age, focused heavily for a long time on classic web analytics. We work with all the traditional web analytics solutions from Adobe's Omniture Site Catalyst to Google Analytics to, of course, IBM and Core Metrics. And our practice is really focused on what I would describe as pretty high-end digital analytics and customer analytics. We do a lot of digital segmentation, a lot of site optimization and personalization, customer analytics, attribution modeling, things that often really demand a lot of horsepower in the solutions we're working with, and often demand a lot of data too. So this is a world we've been pretty heavily exposed to. And I think from my perspective, I come out of the traditional BI and statistical analysis world, and I sometimes think of the problem that we're facing today and that our practice is trying to solve as really to bring together two worlds. I look at a lot of our clients, and what I see is that most of them have really sophisticated BI and customer analytics departments. They have significant web analytics and digital, but the two groups really aren't talking effectively. And a lot of times over in the BI and customer analytics worlds, there's deep methods, there's a lot of learning, there's powerful tools, but they haven't really grasped how to use digital data. Whereas over on the digital measurement side, people have a lot of expertise in the data itself and what it means and how to think about it, but maybe not the same level of expertise working directly with large amounts of data and with the kind of tools that are necessary to really generate interesting analysis. So I sometimes talk about our goal, and I think in some ways this is the goal, the underlying goal for the whole presentation is to take these two worlds, that traditional world of BI and statistical analysis and this new world of digital analytics, and take all that good stuff that's living over there and apply it over to web and digital. So I think that's underlined a lot of what we're talking about today, and that's really the point of what brings us together.
Yeah, thanks, Gary. So we hear the term big data, right, often used in conjunction with digital analytics. And big data world means that today we do have access to, let's say, enormous amount of data that's being generated at rapid velocity, right? Also, the types of data that we are dealing with today is very heterogeneous in terms of structured and unstructured data. And most people, I think, understand that when you're dealing with digital data or digital analytics, you're dealing with large volumes of data. But Gary, is there something more than that? Is it just large quantities of data that makes digital analytics challenging, or are there more considerations that's really what's causing this, some of these concerns?
Yeah, I think it's interesting. I think everyone throws around the term big data these days, and it's hard to know exactly what to make of that. Obviously, one piece of that is a heck of a lot of data. We are spinning off a lot of data these days, but I don't think that is all there is to the story. And sometimes when I think about big data, and when I think about digital data, maybe as a paradigm case of that, there's really a couple things I think of that maybe go into the equation of what makes for big data. And the first one is, hey, yeah, lots and lots of rows. It makes everything harder. The more rows you have to spin through, sometimes even loading this data is a big challenge. But I think there's a couple other things that are really challenging about digital data, and also I think that are really wrapped up in the concept of the way we think about data. One of them is that digital data has a lot of high cardinality variables. What that means is it has a lot of variables with a lot of distinct individual values. And the way I sometimes describe this to people who aren't familiar with the concept is that if you think about in traditional marketing, a lot of times we work with variables that are classic demographic variables like gender and age and income. Well, it doesn't matter how many millions of people are in your data file. There's only two values for gender in there. And if you want to do an analysis that looks at like gender by age or gender by purchase or age and gender by purchase, it's really easy because you only have a couple categories to roll up. But when you start looking at things like websites with tens of thousands of pages and hundreds of thousands of keywords and refers, or millions of different individual elements in their product set, then you have a lot of dimensions. And when you try to cross-tabulate those dimensions, when you try to look at page name by refers, by campaigns, what you start to see is that you get lots and lots of data in the cross-tabulation, too much for traditional methods to handle. So high cardinality is a big challenge for people. I think another thing, though, and to me this is maybe one of the most significant things about what makes big data, is that in many respects it's a change in analytic techniques. It's a change from analytic techniques that are focused on roll-ups of the data and aggregations of the data to analytic techniques that drive down to the customer level or even beneath the customer level down to the individual touch or server call level. And I think that's a fundamental change. The analytic methods that we're using these days on this data are quite a bit different and quite a bit more powerful. And I think in many respects, when I think about big data, it doesn't necessarily have to be that many rows. When you're driving down to this individual level of detail and using analytic methods appropriate to that, a lot of times you have all the challenges of big data, even if you don't have that many rows. And then the last thing, and this is something we're going to talk about quite a bit in this presentation, and I think it is one of the really unique challenges to digital. In most cases, as traditional analysts, we're used to kind of having meaning at the row level. We think about typically like a customer record, and when we run a bunch of customer records through an analysis, it's really pretty easy, and each customer record is a distinct customer. It's a level of meaning, and most analytic techniques are built up so that they function best when the level of meaning is identical to a row. But in digital data, most of our digital sources spin off lots and lots of rows, none of which have a lot of meaning. And the meaning is often captured in the path of the aggregation, the way someone navigated each of those things. If you think about a visit to a website, every time you hit a page, it fires off an event, and that becomes a row in your database. But there isn't a lot of meaning in the individual page view event. The meaning resides somewhere at the level of all of those page views put together. Well, that's really, really tricky to handle, and I think a lot of the analytic techniques we use aren't very good at that. And so when you drive down to that stream data where the meaning is not trapped at the individual row, it changes a lot of stuff that you have to do.
And these are definitely unique challenges, right? And most organizations today would say, hey, we rely on our underlying data platform, and which may be a traditional database or data warehouse to support their analytic needs. And we often hear the term, hey, it's very painful, or you know, it doesn't scale, or there are a lot of challenges with those traditional technologies which doesn't enable them to handle the needs of digital analytics. So what are those characteristics? Why does it make it so challenging for traditional technologies?
You know, I think it's a lot of the things we just talked about. And if you think about it, a lot of traditional technologies with databases and stuff, they obviously weren't set up to handle, in some respects, tables with really large row volumes. And a couple of things about that, you know, when you and I probably both went through this of doing traditional DBA type work, and one of the things we always wanted to avoid was a full table scan, right? The whole point of building all your structures and indexes was to get away from doing full table scans. Well, as your data gets really, really, really large, that gets worse and worse, right? But if you think about some of the things I just talked about, where the analytic methods are driving down to the detail level, all of a sudden you can't rely on aggregations of the data. So a lot of systems that were built really to avoid full table scans don't work well in that kind of analytics environment. It's also true that the more data you add, your indexes get more and more unmanageable. They get larger, and a lot of times, and we see this with a lot of traditional technologies, it gets to the point where you can't even keep up with the loads of the data. It takes you as long to load the data as it does to generate the data, and clearly that's sort of a self-defeating proposition. I think, too, you know, I talked about some of the high cardinality stuff, and certainly one of the most traditional analytic strategies was just to aggregate the data up, you know, take that data and aggregate it up by gender and by income and by product, and then do the analysis at that level. But high cardinality makes that tricky, and in addition, we're finding that a lot of the analytic techniques we want to do, they can't rely on that kind of aggregate. So I think there's a whole constellation of things going on here that make this very challenging, that make ETL, traditional ETL on the data difficult, that make traditional aggregation on the data difficult, and make even the basic stuff of loading and processing the data very difficult. I'm sure this is something you've been through, Krishna. What do you guys see as you look at this set of challenges?
Yeah, we see the exact same challenges, and then what we're also seeing is, you know, how people are trying to overcome this using their existing environments, right? So that the most classic method is, okay, as you pointed out, full table scans are painful, and you know, we still have to look at all the data. So what do we do? So one technique is, all right, let's create indexes, right? Or let's create these secondary optimization techniques wherein I don't have to necessarily look at every element of data. Now, the problem with that, Gary, is that then you have to almost you know, upfront define what are the type of questions you're going to ask, right? If you have to define indexes, you have to optimize your data based on the type of question. You have to almost know what you want to do, and that defeats the whole purpose of free-flowing ad hoc analytics, right? So that's where the real issue comes down to is, you know, where either do we have to, you know, spending time and effort on managing all these different controls and indexes and partitions that you have to create to manage data versus, hey, let us just leave data as it is in its rawest form, and then at runtime, let the system figure out the best way to deal with it, right? So that's what they're grappling with today.
Yeah, I agree with that, and I think it's really interesting when I think about this last question that you mentioned about how analytics needs to be more ad hoc and free-flowing, and I think that's true, but I also think that even if you sat down and pre-planned every kind of analysis that you were going to do, one of the problems these days is that once you drive down to the customer level and beneath the customer level to do your analysis, every single analysis requires a different set of aggregations. And it's not that at some point you're not aggregating the data. Maybe you are. You're not always. Sometimes you're down there at the detail level for the whole analysis. But even when you're aggregating it in a different way. So even if you think about it, you say, hey, I know the 10 analyses I'm going to do. Well, you know what? Once you sit down and think about that, no one aggregation is going to work for all of those. And I think that's a huge challenge because it's not simply that you need this weird ad hoc free-flowing environment. You do need that. I think analysis often is ad hoc, and I think anyone who's ever done analysis knows you rarely get it right the first time, right? You have to try it a couple of times. You have to experiment with the data. So that level of flexibility is really important. But in fact, even if you were the perfect analyst and you knew exactly what you were going to do, I think what you'd find is that for every single analysis you did, you'd still have to do a set of custom aggregations, and that's just not acceptable.
Yep, and we see, and to that point, Gary, we are almost seeing organizations set up two different types of analytic environments. For lack of a better term, they use the term productionizable analytics, wherein, we're running some predefined set of analytics that are repeatable. And then the other is what they call exploratory analysis, right? So we also we have all this data and we want to find nuggets of information, or we want to explore this to see what kind of stories data tell us. And we don't want any constraints on that, right? We just want to be able to do that in a free-flowing manner, right? So that's sort of how we are seeing the digital analytics realm evolve. But all of this really, right, the quality of analytics really depends on the underlying data, right? Its structure, its type, and all the good things that make up data. And when we work with our customers, these could be, really large banks or retailers, and they all have tons of data, and they all have been managing data for decades now, right? For instance, they may have customer demographic data, they may have point of sale data, and they seem to have a good handle on that type of transactional data. However, when it comes to digital data, especially data that is generated by, let's say, user engagement on their digital properties or marketing activities on their digital channels, they always seem to struggle with managing that. So what is unique about digital data itself, and how is that different from, let's say, traditional transactional data?
I think this is a really interesting topic to me. Coming out of that traditional database world, when I first started doing digital data measurement and analytics, to be honest, I saw no reason why it ought to be different. And I think I came over to this world thinking that, by and large, the same techniques that I was using when I was doing credit card database marketing and analytics were going to work in the digital world. It turned out that was a somewhat optimistic view, I guess, and after working in digital for a long time, I've come to the conclusion that, well, there's a lot of similarities. There's a lot of things that are the same. I'm not going to pretend that there's some new magic here, but there are some differences, and some of them are pretty important. And I guess as I've thought about it, I've really come up with 4 things that it seems to me are fairly different as I look at our experience in digital data and our experience in sort of traditional customer analytics. And the first one isn't so much to do with the data. It has more to do with the domain. And I think over time this is probably going to change. But I know when I did traditional BI and analysis, one of the things was that we could often rely on a domain expert. When I was talking to financial folks, when I wanted to understand their requirements, I could walk into their office and I could ask them, what do you need? My job was to get the data and do the analysis, but they could tell me exactly what data they needed and how they wanted it and how they were going to use it. In digital, I found that's often not the case. There aren't really domain experts. A lot of times in digital, the analyst is the domain expert. People don't understand the terminology well enough yet. It isn't deeply embedded. It isn't taught formally in schools. And so I think one thing I found that's just a change in the way the community works is that as an analyst, you can't rely on someone else to be the domain expert. You almost have to be the domain expert. That can be frustrating and a bit of a shock sometimes for people that come out of that traditional world. The second one, though, and I think this is one we're probably going to get into in a little more detail, but I think this is this is something that really is fundamentally different. In my past life, most of the data I dealt with, it was row-based analysis. I was dealing with customer records, customer-level data. That's very traditional for people. Analytics data isn't like that. It's stream data. And all of those page views that you get off a website, or those events you get off a mobile application, or those tweets you get off something in social, it's not that it's all unstructured. Only social data is truly unstructured. Most digital data actually is at least what I would call semi-structured or structured data. What's different about it is that it's stream data. And what that means is that each one of those rows is not the significant entity of analysis. That's a real change. And so to get to a significant entity of analysis, you have to aggregate that stream data up into something interesting. The analyst has to do that. But here's where it really gets tricky, because this is the third bullet point here. I don't think the stream data aggregates very well. When I first started doing segmentations in the digital world, I was doing customer-level segmentations, and I said, well, I'll just add up the number of page views and the number of visits and the time on site for people, and I'll use those as my segmentation variables. And what I got was a really lousy segmentation. It was like a big step pyramid. At the bottom, there were people who viewed one page on the website, and then it went up to 2 pages, and then 3 pages, and it was totally useless from a digital marketing perspective. And I think that's because those stream variables in and of themselves aren't interesting. You have to come up with different aggregation strategies. And I think this is really challenging for people who first come to the data. There's a tremendous tendency to say, hey, if a guy had 30 page views on the website, the interesting aggregation is that they had 30 page views, and that's the variable I use. That's not the interesting aggregation. The meaning comes from what those pages were and how they were related in the session. That's the art of sort of working with digital data. And then this last one, we're not going to talk about this a lot today, but it's something I think is pretty interesting as well. Websites have a formal structure that really influences the way people use them. Mobile apps, too, to an even greater extent. So when you do traditional analysis on this data, one of the problems is a lot of times the structure skews the analysis. And I've seen a lot of really good statisticians sit down with digital data, run a big fancy analysis, and come back with the most banal conclusions, like the sweet spot for conversion is people who viewed 5+ pages, and you go look at the website, and it takes 5 pages to convert. So I think there's a lot of ways that digital data actually shapes the kinds of analysis we can do and present some really unique and unusual challenges to folks who are first coming to digital data.
Yeah, the whole concept of streams and digital streams is really fascinating, right? I mean, there is because the data here does have this notion of fluidity, right? It's fast, it's changing, it's dynamic, and can grow very rapidly. And and if there was one difference, again, as we talked about why traditional technologies don't necessarily handle this digital data and digital analytics very well, it's because they were fundamentally designed for transactional data, which is very static, and as you pointed out, very row-based. And the type of data fundamentally changes the architecture of how you store it, how you manage, and how you analyze that. And that has far-reaching implications on the technology stack, right? And if you're trying to use the wrong tool to solve this type of problem, then that's what causes all the issues and challenges. So let's talk a little bit more about streams. So you brought this notion as it's very hard to aggregate streams. So why is that? What is it that makes it much more difficult to aggregate streams than other types of data?
Yeah, I put a couple slides in specific to this because this is one of the 4 concepts that I think where digital data is different. This is the hardest one to really get a grasp on, and I think it's something that in our practice we've really just been evolving these concepts and thinking about how different this makes digital analytics. And I think the idea is that okay, I think most people get the idea if they're at all familiar with digital data, that it comes in this stream of events that's flowing through. And this is true whether it's social data or mobile data or website data. Well, one of the big challenges that I think with streams that I really wanted to talk about, there's several different challenges to streams. One is just aggregating it. How do you aggregate this stuff up so that it's meaningful? What does it mean that someone viewed page X and then page Y and then page Z? Is the meaning that they viewed page X, or is the meaning in the path between those things, the fact that they viewed those 3 pages, or maybe these 7 pages instead of those 5 pages? How do you get the meaning out of that? But there's a second problem that I think really, really bedevils a lot of people who are trying to do big data technology solutions, and I think really impacts people. And that's the fact that when data is in this stream form, it's really difficult to join it together. So if you've got this stream of mobile data and this stream of web analytics data, and you park them both in the same box, and you have a key that says it's the same customer, traditionally, IT folks think of that and say, hey, I'm done. right? You know, that I put the two data sources on one box and I put a key between them, I should be ready to do analysis. The challenge is, if the data is in stream form, you really haven't accomplished much when you put it there. And I think when you think about it, when most people are doing big data solutions, probably the single most important thing they have in their mind is joining these disparate digital sources together, putting them together in ways that allow you to integrate the customer journey and look at the customer over time. So joining is an absolutely critical thing. It's probably the single most important thing that you're going to do. And if it's hard to join streams, then it's hard to do digital data analysis well.
Yeah, that's true, Gary. And I think we see this more in digital data context because a customer may have different identities on different channels, right? So when they are browsing your web properties, or they are going through a journey, clicking through multiple pages, they may be very anonymous. You don't necessarily know who they are, and the only way you can track them maybe is via cookies. And then the customer may also have, through a different context, subscribed to your email newsletters, and they may be engaging with you differently. And they may be a fan on your Facebook page, or they may be a follower on your Twitter account. So they have these different types of identities, and then correlating all of them is almost like putting together a jigsaw puzzle, right? So what's the real hard problem with joining?
Yeah, this is one that I think takes a little bit of explanation, and I hope isn't too technical for folks. I'm going to touch on it pretty lightly, and for people who are really deeply interested in this topic, I definitely would encourage you to go read the white paper that IBM and Semphonic put together, where I dealt with this in a little more depth. But I extracted a couple diagrams from the white paper, and just to show sort of how traditionally you think about joins. This top figure one is probably the most common kind of join we do. We've got a customer file that has gender and age on it. We've got a customer file that has account on it. We do a join, and what the analyst gets is a really nice record that has the customer ID, the gender, the age, and the account. And it's really easy to deal with that data. You know, similarly, it's not much different if we join to a file where we have customer IDs, and then we join to another file that has, for instance, census information about the zip code they live in, so like what the average household size is or what the average household value is. Again, when we join this information, even though it's in some ways a many-to-one join, it's easy because we get one record per customer ID. The problem is, if I take this same data and I think about having a mobile stream and a web stream with different fields in each, and I join them together, what you think about is, yeah, I've got the visitor ID, but I can't really join these records. When I put them together, they just interleave. They interleave based on time, right? I'll have a web server call, a web server call, a web server call. Sometime later, I'll have a mobile server call, a mobile server call. I'll have totally different fields describing each. And even though I've been able to put the two together, from an analyst perspective, I haven't really simplified my analysis any. I don't have one row. No row combines here. No actual rows get joined together. So I still have to work with my web data and my mobile data. And even though they're all in one source now, the join itself hasn't really simplified my life any. And I think that's really, really challenging in digital data, because what we see is a lot of times people put this data in one place. They go to all the trouble, and it is a lot of trouble, as you said, a lot of times, just to get the join keys in place. But then analysts have a really hard time working with this because they're used to having one record that combines these two kinds of information. But when we join these files, they don't get that. They get a union of all these rows just put together in a hodgepodge way. And this makes I think this makes digital analysis really pretty darn hard.
Yeah, and I think one of the things, Gary, is we see, when we talk to digital analysts, they feel this pain, and then they're trying to communicate with their IT brethren in the organization as to, hey, we have these very unique challenges, but they're finding it very hard to sort of communicate this, right? And the model and the framework that you're providing here is definitely helpful. It helps them think through, or explain their problems in terms of these concepts like streams and why that's hard and so on and so forth.
Yeah, I think this is one where it feels like for a lot of analysts, once they get this data, that it ought to be easier than it is. And I guess having gone through these experiences and tried to really work with this data and been frustrated ourselves with it on a repeated basis and gradually learning what does work and what doesn't, I think we've come to realize that some of the things that we thought in the traditional world solved problems in the digital world aren't necessarily complete solutions, that there's still extra work you have to do when you bring these data sources together to put them in a format that makes it possible for an analyst to really take advantage of them. And I think, all of this stuff, the challenges in streams, the fact that you're working with detail level, the fact that you're working with a lot of data, all of this stuff, I guess the reason we've spent so much time on it is it has a profound impact on the technology stack, right? I mean, this is stuff that ultimately is really going to drive how you think about the technology stack you choose and what you have to do to have a technology stack that's effective in this space.
Absolutely, and I think we're also seeing a lot of technology solution providers and vendors coming out in the marketplace, and they're touting themselves to be, let's say, web scale or digital analytics ready, right? And there's a lot of that, and that's good in a way that we now have solutions to this problem. But on the other hand, analysts are just struggling to figure out, hey, how do I even go about picking the right technology, right? I mean, what's the framework? What's the methodology? Because each of these products seem to have some unique capabilities, but how does that translate and map to the problems that I'm solving?
Yeah, I think that's a big challenge. I know we're getting asked by a lot of people these days to sit there and think about, well, geez, there's all these new technologies. They all sound cool, but they're all different. And in some ways, it's hard to get a grasp on why they're different and what different problems they're going to tackle. And I guess one thing is, as we sat down to think about this problem about, well, how do you do this kind of choice? I guess what I would say is, first, don't have a homer moment. I think that the key thing anytime you're thinking about a technology is pretty obviously to start with what you're going to use it for. And one thing I realized as I sat down and thought about our experiences doing analysis is that, in fact, one, there's a lot of different things wrapped up in the idea of digital marketing and digital measurement and digital analytics. And, in fact, as I thought about the way we did and the way we approached the data and the way we did the measurement and analytics in these spaces, that they actually have some pretty different and distinct needs. So I think one of the first things to start with is don't just assume that your digital marketing is all one thing and that you can go look at a technology stack independent of what you're actually trying to accomplish with that digital marketing stack. This may sound blindingly obvious. It is kind of brutally blindingly obvious. I hope I'm preaching to the choir here. One of the things we tried to do in the white paper, though, was to go into more depth here to say that, if you think about each of these things, whether if what you want to do is advanced web analytics, so you really want to look at detailed pathing and behavior, you really want to understand things like how I mentioned earlier, how site topology can really influence the relationship and the correlation between pages. If you want to solve problems like that and really do interesting advanced web analytics, you need a more advanced solution. You need a big data solution. But that puts particular kinds of stresses on your technology stack. There's particular things that kind of analysis requires that in fact are a little different than if what you want to do is customer modeling, or if you want to drive site personalization or personalization across emails. There are very distinct things that you need in the technology stack to support that. If you want to do targeting. So yeah, Krishna, go ahead.
Yeah. So, and one other thing, Gary, is that we are also seeing, there's an evolution from specialized tools that used to solve each one of these problems individually, right? So you had these web analytics measurement tools, and you have a different email targeting tool and a different social media analytics tool. So we are now also seeing a sort of a convergence of the underlying platform in some sense, because as a marketer, these are all activities you may want to perform, but the underlying data to a great extent is similar and they're all the same, right? So you still want to, in some shape or form, aggregate that data in one place, but then drive each of these as use cases on top of that data.
I totally agree with that. And I think, there's always trade-offs between sort of dedicated solutions to a particular point and a broader generic solution. But I absolutely agree that first of all, I think there's a lot of economies of scale and a lot of benefits to be had through driving to a more standardized platform. I think another piece of that that's almost equally significant is people are realizing in a lot of cases that when they do targeted platforms to one of these things, they end up with a very siloed view. I think this has happened in my space is web analytics, and I think one thing that people have realized is, hey, there are great web analytics tools out there, but all they tell you about is the customer's experience on the web. And increasingly these days, the analytic techniques we want to do expand across channels. They expand across things that a particular tool is looking at. And a lot of times you really have to have a pretty broad understanding of the customer, the channel touches, their journey, and your products and your customer, your whole organization set, you have to be able to put a lot of that data together to really do an effective analysis. So not only do I think there's economies of scale and benefits to generalization, I think for a lot of these techniques, it ends up being really important to have that broader general platform because it gives you views of the data and the customer. Otherwise, you're just never going to get out of a siloed solution.
Yeah, that makes sense. And then how do you kind of go about picking the criteria or the decision vectors associated with, identifying what that technology stack or the underlying platform should look like?
Yeah, so that's sort of the second step we did in the white paper. Is in the first step we sort of laid out, okay, here are a bunch of classic digital marketing types of things that you might want to do, ranging from loyalty program analytics to customer modeling. And for each of those, we laid out the way they stress a technology stack. And then in the second part, we sort of looked at, okay, then how would you actually assess an individual technology stack? If you're looking at Hadoop, if you're looking at a database appliance, if you're looking at an MPP system, how do you think about that technology stack and how do you dimensionalize it? And we sort of came up with these set of vectors as things that, beyond the obvious stuff like price and the vendor support that comes with it, and things that probably go along with any technology solution. These are sort of the things that we came up with as being distinct across different technologies. One is just their ability to handle huge row volumes. There's some pretty distinct differences here, and you'll see technologies that sort of splay out along a continuum in terms of their ability to really handle lots and lots of data, their ability to load it, and their ability to process it. There's a second thing that I think is really important here, minimizing data modeling. I think we talked a lot, earlier about just the fact that so much analysis these days has to be at the detail level. Every analysis is unique. A lot of it has to be exploratory. What that means is you can't have a solution that demands a lot of data modeling. That's really impractical if what you want to support is an analytics smart. Ease of data integration. Streams, obviously we've talked about the importance of integrating streams, and solutions differ dramatically in their ability to really allow you to integrate data, and that's certainly one of the key things I think you want to look at with a technology solution. And then if you're talking digital marketing, support for integrated marketing solutions is obviously really, really important, right? You want to be able to not just do segmentations, you want to be able to drive that out, so your targeted marketing programs. So I think integration with other solutions, that's something that a lot of these new technology stacks are not great at, and that's something you really have to think about as you look at your choice of technologies for big data. Support for BI tools. There's a huge set of really powerful tools out there that most of our clients have a lot of significant expertise in. Making sure that your tool set really that your underlying technology for database supports that tool set is really important, and the same for advanced analytics. That's an equally important thing. If you get the platform, but you don't have the software tools on top of it, it's not going to do you a heck of a lot of good. And then lastly, the expertise available. Obviously, one of the things we're seeing is, a whole new set of technologies emerging in the marketplace. A lot of times they're very expertise challenged. It's very hard to find the resources to run these things. It's definitely a risk point for a lot of organizations we've seen. Definitely something you have to think about as you're deciding on this.
Yeah, and then there's also a simplicity aspect to this, Gary, that we're seeing that some of the technologies are better at than others, right? So, just take, for example, handling large volumes of data or performing integration. The question you need to ask is, how easy is that? What type of skill sets do you have in-house? Do you have the right DBA skills, or do you have developer skills? And does that align with the mechanism that those tools provide in terms of how you want to achieve those goals?
Yeah, absolutely. I think that's really important. And just to sort of show how we end up kind of mapping these things, I took one of these particular problem sets, advanced web analytics. It's one I'm pretty deeply familiar with, and mapped it. So I first mapped the problem set against these things. And when you want to do advanced web analytics, it's pretty important to handle huge data volumes. So I gave that a pretty high score, an 80 out of 100. It's vitally important, absolutely essential to minimize data modeling. So I gave that a top score. Easy data integration is pretty important. It's not just web analytics. You do find that you have to integrate other types of data. Support for integrated marketing solutions, not a key decision driver if you're just looking at advanced web analytics, so that gets a low score. Support for BI tools, I gave that a kind of moderate score. If you're doing advanced web analytics, those tools are kind of interesting, but they're not always essential. But support for stats tools, that absolutely is. And what you'll find a lot of times is that the performance of statistical tools varies a lot across technologies, and that's really important because we're talking about lots and lots of data that you're trying to analyze here. Expertise available, I consider that one pretty darn critical for this. Support for algorithmic queries. You know, we find that these days, if we're really going to do interesting analysis on complex things like websites, a lot of times we can't use canned statistical procedures. We have to do procedural algorithms for it. This is something we consider pretty vital for this problem space. On the other hand, you don't need real time. You're not as concerned about minimizing administration because it's a relatively static data set once you bring it in, and you're only modestly concerned about uptime load without disruption. So that's kind of how I map this particular problem space in terms of these decision vectors. And then what you can do is take a particular technology, and in this case I picked Hadoop just generically, and I mapped it against these same kinds of vectors. And I think what this gives you is a really interesting way to look at how a particular technology compares to a particular use case, where you're likely to have stress points, where the technology more than meets your needs, and where it may be underperforming the needs you have, and maybe you need to look to supplement that kind of technology.
That's true. So, so is that an illustration? I mean, you obviously had something like this in the white paper, Gary. So how do you kind of bring them all together and map it to your existing use cases?
Well, I think so. So what we did, and this is just lifted right out of the white paper, is just all the different use cases across all the different decision factors, scored by how important we think they are. So this really gives you that kind of vectorization and gives you an easy way to start thinking about, hey, if these are the things that I want to accomplish, if my goals in building a big data technology stack in digital marketing are to support things like social media analytics or loyalty program analytics or email targeting, these are the things I really should be focused on. And hopefully, you know, this is just a framework. This is just a way I hope to get people thinking about, from their business requirements to the technology stack, exactly what they're looking for and exactly where a technology stack's likely to pinch.
Sure, and let's say people use this type of framework and pick the right technology stack, right? So what happens after that? So from a practitioner's point of view, where do you think customers make mistakes during their implementation? What are some of the common failure points?
You probably have as good a sense of this as I do. I'm sure as you've seen guys fail, and I've seen guys fail. This is hard, and I think a couple things I've seen people go wrong on, and then I'll kick it back to you. But I guess, you know, a couple things I've seen is sometimes wanting too much data. I see sometimes as people sit down and look at the requirements and say, hey, I want 5 years of data. But as an analyst, I know that I rarely look at 5 years of web data. The websites have changed too much. Behaviors change too much. Don't insist on more data than you actually need to accomplish your purposes. I also see sometimes people insist on using a single technology. Hey, Hadoop's got to solve every problem, or you know, whatever technology I pick, it's got to do everything. That's not probably going to be the case. As you look at the range of requirements you have and you look at the solutions, you may need different technologies to solve different problems. I see people ignoring ETL too much, not realizing that they have to do a fair amount of ETL on this data to make it meaningful for their analysts. Integration, we've talked a lot about reckoning with streams. I see people parking data sets on boxes and assuming they're done and the analysts can use it, and that's just often not the case. I often see people just not, as I mentioned, understanding the fact that topology on websites is really important, so the analytics goes seriously wrong. And then I see sometimes, too, people just having unrealistic expectations. They'll pick a really good technology stack for most things, but then they want it to do real-time analysis, and maybe it's not set up for that. So I think making sure that you adjust your expectations and don't over-demand on a technology stack. I think those are probably the most common failure points I see as I see people laying out these digital marketing big data solutions.
Absolutely, and we also see, Gary, off late where organizations are picking technologies, but they are not necessarily aligned with the skill sets they have in-house or skill sets that are available in the market, right?
You're right, yeah.
So Hadoop's a great example. We had one of our customers that had a large set of relational DBAs, SQL-based DBAs in-house, and then they adopted Hadoop, and it was a slightly different paradigm of managing and running that system, and they didn't have that skill set. So now they're grappling with, you know, either finding the right talent from the market or training their individuals into this new model. So not that that's a bad thing. I'm just saying that that's a consideration, and that needs to be built into the the whole model and in terms of project timelines and everything else.
Yeah, no question. No question. Totally agree with that. Well, Krishnan, I guess we've gotten to the point where we've sort of talked about the framework for analyzing it and thinking about a digital technology stack. I know this is a problem you've pondered deeply from a business perspective and a personal perspective. I mean, obviously this is core to what you guys are doing and what you're doing personally at IBM. Talk to me a little bit about how you guys have thought about, just the IBM big data stack and how you think about it.
Sure, Gary. So you kicked this off talking a little bit about the paradigm shift, right, and why, what are some things that are very unique about digital analytics and why that makes it a very difficult problem to solve. There's obviously lots of data to manage. There's a focus on analytics, and there are challenges with aggregation and so on. And one of the best practice mechanism to think about this is to first think of a big data platform, right? So a platform that can store all the data in one place, provide deep analytics, and can scale without large human effort or huge capital investments, right? So that's what we did. We sort of have established the need for a type of platform, and at IBM we said, okay, fine, if we are going to build that platform as a solution for our customers, what are the capabilities or requirements for that platform, right? And so we started thinking about it from that perspective, and we said, okay, what would that platform look like? So obviously it should have the ability to ingest all types of data, be it online data, impression data, cookie data, be it coming from an Omniture, Core Metrics, or Web Trends, and in some cases ad servers like a Google DoubleClick, right? So it should have the ability to bring that all in. It should have the ability to ingest social data, third-party data, segments and responses, and so on and so forth. So the platform will have to scale. It has to have the ability to have heterogeneous data types inside of it, and all of that. And then it should also be able to perform different operations on this data, right? So we talked about large volumes of data, and that's a given, right? So scale without huge human effort, and it should be able to do that. But more importantly, it should also be able to handle the diversity of data, right? So we are seeing organizations managing not just structured data, right? And a big majority of the data, especially in the digital realm, is still structured. But there's also the semi-structured or unstructured type data like impression data or clickstream data, and unstructured data like social data, right? So instead of putting these in different platforms or different containers, it makes logical sense to have them all together, because when you're analyzing a customer journey, you're looking at that journey across all their different engagement paths, be it social or be it mobile or even the web-based clickstream activity. So as a marketer, as an analyst, you're putting them all together, so it doesn't make any sense to store this data in different repositories. So that's another critical thing. And we're also seeing the need to analyze data in real time, right? So that's becoming increasingly important, because the type of solutions that we are building in terms of product recommendations or real-time offers or targeted ads, they all act on on a very tiny time window, a matter of milliseconds, right? When your customer is on a specific page or in a mobile app, you want to immediately hit them with very specific messages. So that real-time analytics becomes all the more important. And then we also are seeing this need for, go ahead, Gary.
I just wanted to ask you a question here, because this is something that I see as a tremendous stress on a big data technology stack, right? I mean, my sense is from the outside that this is maybe one of the hardest things to accommodate. Would that be your sense?
It is. And the way we actually have thought about this is we classify data into two categories. There's analytics into two categories. There's analytics in motion, right? Then analytics at rest, right? And what that really means is, we've been traditionally when we perform analytics, we deal with data that is resting. It's in a database, it's in a file, it's on storage, it's sitting there, and then we are analyzing that, right? But there's a new class of analytics occurs on data in motion, which means the amount of time it takes to capture that data, store that data on physical disk, and then query that and then analyze that is not good enough when we have to make millisecond type responses. So we really have to act on data as the data is moving, as events are occurring, right? So when you apply that type of a framework and you start baking those concepts into our platform, it makes it a lot more easy from a solution perspective. But you're right, it is a hard problem to solve, and we've got to kind of gotten to a point where we have commoditized some of those aspects.
Cool.
And then and we talk about any platform. We talked about analytics and all that, but the whole notion of discovery and experimentation is key. Just because this domain is new, this whole digital marketing sphere is relatively new. A lot of analysts are always trying to sort of figure out things as they go, right? They want to be able to have enormous flexibility in discovering relationships and discovering new meaning in their data. And so the platform has to have that flexibility, right? It has to have the flexibility to issue any type of question or query and scale and answer that very quickly. And then finally, when we talk about any platform that deals with data, it has to be enterprise hardened, right? It has to be able to provide the right set of governance mechanisms to manage data quality, administer different levels of security and access control, and optimize workloads based on different types of users, right? So that's what makes this a platform as opposed to a tool, right? So we took all these different types of requirements, and then we said, okay, now that becomes our basic foundational offering called IBM's Big Data Platform, right? And that's what we go to market with today in a couple of different forms. So one is we realize, obviously, that the physical containers for these different types of requirements are slightly different, and so we have three key ingredients or three key data engines, so to speak, which make up our big data platform. So there's Netezza, which is our relational, massively parallel data warehousing appliance. It is designed for extreme performance. It's designed for low latency analytics, especially if you have to deal with hundreds of terabytes of data. And then it's delivered in an appliance form factor, so it's very simple to use, it's simple to manage, and so on and so forth. And then we also have this technology called Streams, which is designed for acting on data in motion, right? So especially as events occur, if you want to capture that, if you want to aggregate that, and then you want to take actions on top of it or run analytics on top of it, Streams becomes a great conduit to do that. And we talked about Hadoop a little bit earlier. Hadoop's a great technology for solving a certain class of problems, right? Massive unstructured amount of data, or you want to do some pre-aggregation of large volumes of data. But in cases where latency is not that important because it's still a batch mode type of operation. So we have an offering called Big Insights, which is IBM's distribution for Hadoop, and it has a whole set of accelerators and packages for analytics. So and all these three different components, the way we have architected them is they're interoperable with each other. There is a seamless transition of data across all of them, and then we have a common framework for defining analytics on top of that. So that's the way we look at this world. We think of this platform as being key. And then one of the things now we're also doing is we are integrating this with all our existing marketing tools like Unica, NetInsight, and Core Metrics, and so on and so forth. So we have turnkey soup to nut solutions for different types of digital marketing problems.
Krishna, tell me something. I guess one of the questions that we had come across, I think, gets to a question I kind of have, which is, as you look at this platform, it's my assumption that in most cases, people would be deploying more than one piece of this. How often do you see that? And is that something that's evolving over time? I talked a little bit in the failure points about how I often see people fixate on one technology. Do you guys see that, and how do you feel about do you see a growing tendency for people to deploy multiple pieces of this, all pieces of this? Are there situations where, I'm assuming there are going to be at least some situations, if you don't have a need for real time, you're not probably going to be deploying Streams, but what's your sort of sense on how often people need to put all these things together, how often they can deal with one of them on their own?
Oh, absolutely. That's a great question, Gary. And what is inherent in this platform is the notion of a roadmap, right? So there are these three different data engines, but you don't necessarily have to turn them all at once. We typically see the first investment most of our customers make is usually a Netezza type investment, right? So that's your massively parallel data warehouse, because that can solve about 80–90% of the problems that we described earlier, right? So you have data that has the streaming characteristics. It's hard to correlate. Full table scans are very expensive. So most of those problems sort of go away with just moving to a massively parallel structured relational data warehousing environment that's optimized for analytics, that has deep integration with BI tools. So that's typically the first step. And once you get to the point, then we see customers kind of go in one or two different directions. They say, hey, we have those use cases where we want to do real-time targeting, where moving data into a platform like Netezza, it might take a few minutes, but that type of latency is not enough, is not acceptable. We have to really target customers as they are on our website or on a mobile device. So Streams becomes a logical extension to enhance that capability, right? And it's not like you have to rewrite your analytics. The way we have designed this is you can actually take some of the analytic models that you're running on Netezza and then seamlessly move that over to Streams. So that's one way you extend it. And then the other way you extend it on the other side is, all right, now I have all this data, and I'm, traditionally people would archive their data coming off of their relational databases into tape storage. But now that commodity-based storage is so cheap, they're trying to do is say, hey, let's just move data outside of this critical hot window into a queryable archive, and Hadoop becomes that queryable archive, but it sits there forever, right? And if you have queries which can kind of go, which need to access historical data which is outside of this relational environment, then you can go and either pull that from Hadoop, move that to your relational environment, or access Hadoop directly. And another use case for Hadoop would also be some sort of pre-processing, some sort of pre-aggregation on large volumes of data, or even to manage some of your unstructured data. One example we see commonly is people bring in all their social data like tweets and such into Hadoop, use our text analytics library to extract sentiment, and then push that into Netezza. So there is an evolutionary path, right? So you start with one of these engines and then keep adding other engines based on your needs. What we're trying to do from an IBM's perspective is make that transition seamless and make the interoperability across all these components fairly easy. So every time you sort of have this new requirement, it's not something you're starting from scratch.
Krishna, there was one thing you touched on there that I wanted to touch on as well, which is that I know that each of these platforms in their own way can deal heavily with raw detailed data. And a lot of times I get asked, you guys say that dumping streams on a box does not solve this problem. And then I hear from people that, but wait a minute, the box just is supposed to take these unstructured streams and process them. One thing we definitely see is that the technologies we're talking about here are highly optimized to work with table scans against lots and lots of very low-level data. But very low-level data doesn't always mean the lowest level data. One thing we believe is that a lot of times to get that meaning out of the digital stream data, you need to do some very low-level aggregation of those streams into visit-level or sub-visit level aggregations, units of work, to derive the meaning about what that stream of page use means. That's a great task for Hadoop, and we think Hadoop is a really plausible ETL tool, processing data to then put it on into platforms where maybe there's a little more analytic power and richness in the tool set. So that's a case where I really think that those two fit together really seamlessly. And Krishna, you sort of answered this question, but maybe we had a question come in from the user that I think maybe needs a little more elaboration. I think you touched on this, but the question is, what part of the offering really addresses unstructured data? Can you talk to that a little bit?
Sure. The Hadoop offering really addresses unstructured data. And again, I want to clarify what we mean by unstructured data, right? So in the digital analytics realm, there are two types of data. There's user-generated content, right? And this is stuff like, where if somebody went into Facebook and typed text on the status page, or they tweeted something. So this is content generated exclusively by users. And then there's machine-generated content. Machine-generated content are stuff, if a user clicks on a button or visits a page, that data is being captured via some sort of a beacon or an ad server log, and it's captured in flat files. So there are these two subtly different types of data, and they both have characteristics of being, high volume, high velocity, and so on and so forth. But the user-generated data is what is typically unstructured, and you want to first analyze that. You want to first be able to correlate that. In the case of social data, the most common use case is to extract entities, or you want to extract sentiment out of that. And then Hadoop is a perfect platform to do that. And then once you've done that, and once you have structured data, and even in the case of machine-generated data, it's fairly structured. You tend to bring that into a relational world because the tools out there in the marketplace today are much more sophisticated in handling relational data, and it also has an optimizer that helps you reduce query latency.
That makes perfect sense, and I think, Krishna, we're at the top of the hour, so I think it's probably time for us to wrap up. I will just housekeeping notes. We always get asked, will slides be available, and is the webinar being recorded? And the answer to both is yes. If you're listening to this, you registered, and you'll get an email in a day or two that points you to both those things, so that you can get the slide deck, and you can listen to us in all our glory doing this all over again. Krishna, it's been a pleasure. Thank you so much. I really enjoyed it, and I hope all our listeners have too.
Thank you, Gary.
Thanks, guys.